So in this case, we are asked to use the binomial theorem to find just the fifth term of this expansion. So this one's the power of 5, so we're looking for the last term. This one's the power of 9, so we're looking for the fifth term there. And I'm sorry, this one's actually not the last term. It's going to be the second to last. And same thing here. Instead of expanding this one out to the power of 7, and that has 8 terms, I'm only going to find one term. So what we need to do is establish a pattern. So look up here at the binomial theorem. This right here will yield me the first term. This right here will yield me the second term. This right here will yield me the third term. So if we were to establish a pattern, this is my first term, my second term, my third term. Notice I do not see a 1 up here. I don't see a 2 up here. I don't see a 3. But what do I see? I see pretty darn closeness. Instead of a 1, I see a 0. Instead of a 2, I see a 1. Instead of a 3, I see a 2 right here and here. So in order for me to find a particular term or a specific term, so let's say I want to find term n. What do? Then I'm going to say n minus 1 is going to go here and here. Notice here and here are the same. And over here, the 2's are the same there. So let's see. So for this example down here, we're asked to find the fifth term. So what numbers should I see in there? I should be seeing a 4. So this one here begins at 5. I always have a C, and instead of my fifth term, I am finding my fifth term yields me a 4 in the front there. Then I have to take this 3a and put it there. I actually don't know what exponent to put there yet. Remember, I start high there, but I'm counting down. But I do know this negative 4 is going to match up. The exponent here, this exponent always matches with that right there. Excuse me. This r matches with that exponent. So here's I'm finding my fifth term, so that's a 4, and so is that one up there. And what's the key thing about these two exponents? What are they always going to add to? They're always going to add to the 5. So that means this one here has to be a 1, because 4 plus 1 is 5. So I found something to grab a hold of. The fifth term means I'm going to have a C4, and this exponent here is going to be a 4. C4, did you get it? Yeah. Okay. All right. So all we have to do is evaluate just that one thing. Okay, so 5C4. Remember that 5C4 and 5C1 are the same. So 5C4 becomes a 5. 3 to a to the first power is 3a. And negative 4 to the fourth power is a negative to the even is positive. So that's positive. And 4 to the fourth is the same thing as saying 16 squared, 256. And our last step is just to simplify all that with a calculator. And in the end here, we get 3,840a. And that is my fifth term, which is much better than expanding and finding everything and then counting out to the fifth term and circling it. That is a crankload of unnecessary work. All right. So again, we're trying to find the fifth term, so that means I'm going to have C4. I start at 9, so this one here will yield me 9C4 for my very first coefficient. Then I take the x squared, and I'm going to raise that to some power. I don't know what that is yet. And I take the positive 8, and that has to match here, the 4. Now I know exactly what the blue exponent is. Why? Because the 4 plus this has to always give me the 9. So here is going to be a 5. Now, 9c4, if you need to see that worked out, 9c4 means this. And either you use a calculator or you work it out this way. So I'll expand it, 9 times 8 times 7 times 6 times 5 factorial. And down here, 4 times 3 times 2 times 1 times 5 factorial. And the 5 factorials drop out. 4 times 2 is 8, so that drops out. The 3 can drop out with the 6 to get a 2. So now I just have to multiply the 9, the 7, and the 2. So 9c4 is 126. Remember that when you have a power, you multiply your exponents. So the x, it will now be raised to the power of 10. And the last one is just 8 to the 4th power, which is the same thing as saying 64 squared, which gives me 4,096. Okay, it's a good thing we're not raising this one and expanding it all the way out to the 9th, because look, this one term alone is il massivo. I just made that up. It sounded very Italian, though. So this guy gives me 5, 1, 6, 0, 9, 6, x to the DSA power. Holy monkey butt. That's big. Not the butt, the number. All right, so I'm just going to start with the 7 here. 7c, and I'm going to the 5th term, so I drop that down by 1. My a term is x squared, and I don't know the exponent yet. My b term is y squared, and the exponent matches up with that 4. Therefore, 4 plus 3 is going to give me 7. So I put a 3 there. Now I've set it up. Now I have to go ahead and work through this. 7c4 is 35. If you need to see that, where it came from, 7 factorial over 4 factorial times 3 factorial. 7 times 6 times 5 times 4 factorial. 4 factorial times 3 times 2 times 1. Clearly the 4 factorials drop out. 3 times 2 is 6, and I'm left with 7 times 5. Next, we multiply the exponents, power of a power, there, and power of a power, there. Boop, 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 boop. Done.